Hello, everyone, and welcome to this new episode of the Tech Cafe podcast. My name is Khaled ElNaggar. Today, Ahmed, Misbah, and I will be presenting hands on TDD with TDD Cards. Ahmed, I leave the floor to you now.
Thank you very much, Khaled. So, as usual, we'll start with telling you what Tech Cafe is all about. So, Tech Cafe is a startup company dedicated to empowering the tech community and enabling creativity and innovation in the tech industry. In order to achieve our mission, we offer a number of services. So, one of them is this technical podcast, the Tech Cafe podcast. And our other services include technical workshops and technical consulting. Tech Cafe was a community partner for this year's Demo Day, which took place in July, hosted by Startups Without Borders. And we were silver sponsor of this year's DevOps Days Cairo conference, which took part in September. Visit our website to learn more about our different services by scanning this QR or by simply typing www.techcafe.com. Follow us on LinkedIn to receive our latest updates and to follow up on all the coming episodes on the Tech Cafe podcast. We have big announcements at the end of the session, so stay tuned. Whether you're watching us live or watching the recording, make sure to wait until we do the announcements, or basically, if you can't wait, just move to the end of the recording and see the big announcements we have at the end. So I think we'll start first with talking a little bit about the TDD cards. So what are the TDD cards? So the TDD cards is a new agile tool that I invented to guide software teams to collaboratively improve their TDD experience. It's a card deck that is composed of 50 cards, and these 50 cards are organized into 7 categories. Those are based on our enhanced TDD mantra and a couple of other things as well. So these are think, red bar patterns, green bar patterns, refactor, integrate, recommended practices, and measure. So each category has a number of cards that describes recommended practices or patterns under each category. This is how the card deck looks like. And where did the idea come from? So I came across 𝗪𝗪𝗀𝗀𝗀𝗀's collaboration cards, which are supposed to make software teams further improve their collaboration skills. Because as you know, the Agile mindset is all about collaboration. So the idea came from there. I thought that this card deck was great, and I said, why not have a similar card deck for TDD, since TDD is a very important software engineering practice, and the idea came from there. Are there similar ideas? Yes. Very recently, a friend of mine from Red Hat gave me this card deck as a gift. It's from the Open Practice Library, and it's a card deck that basically has all the practices from the Open Practice Library. And yeah, it's exactly the same idea. It's a card deck, and it serves the same purpose. It's something that is supposed to be educational, and you can use it the way you want in order to further improve the team's skills in, the scope of the card deck. So let's start with our exercise for today. So we have a very nice kata prepared for you, and we're going to practice TDD on this kata, and we're going to be guided with 8 cards from the TDD cards. So Khaled, why don't you explain to us the kata that we're going to be using today for our exercise? Oh, Khaled, you're muted.
Oh, sorry. It's Ahmed. We will be using a simple kata from codingdojo.com. Its name is employee report. So a local grocery store has an employee management system, and they need to be able to filter employees that are 18 years or older to work on Sundays because of legal restrictions in the country. And we should be fulfilling that requirement, Ahmed.
Okay, that's great. So that's the kata we will be using. And we will be following these stages in order to exercise TDD on this kata. So this is basically the red-green refactor mantra, which was invented by Kent Beck, but we've added the think phase that's in James Shore's mantra, and we've added the integrate phase from the 4-beat cycle in Mike Hill's microtests. And all of those are guided by recommended practices and measures. So we're going to be pulling cards from each one of these phases, and of course we're going to pick 1 or 2 cards at most from each phase, and every card is going to guide our TDD exercise. So let's pull our first card from the think phase. So Khaled, go ahead.
The user story card from the think phase it explains that user stories are small cards that describe a small piece of functionality from an end user's perspective along with its value. User stories are used by software developers, development teams to collaboratively capture just enough details to deliver it.
Okay, so this card basically talks about user stories. And user stories are a popular format in which agile teams write down their requirements, because you have to start with requirements. And user stories are better than not having requirements at all or writing down very big requirements. So we have our kata, and we know the feature that we're supposed to develop, but we want to write that down in the form of a user story. So Khaled, do we have a user story prepared for the sake of our exercise?
Yes, Ahmed, we collaboratively wrote the following user story. At the front of the card is the user story, and it reads as follows. As a shop owner, I want to view a list of all employees who are 18 years or older, so that I know who is allowed to work on Sundays. And at the back of the card is the acceptance criteria that we should return only employees 18 years or older.
Okay, that's great. So let's go back to the TDD card and see the questions that it raises. So it asks whether we've written the user stories collaboratively, and the answer is yes, indeed. We did collaboratively write the user stories. And it asks whether we've used the popular 3-part notation, and indeed, our user story does follow the 3-part notation. So as a who, I want what, so that a why. So we've got an actor or a persona, we've got the functionality, and we've got the value that we are supposed to be delivering from implementing this functionality. And finally, it says, do you apply 3 C's and invest criteria? So without going into very much details, you can read further about this or check out our coming TDD workshops. But yes, we do implement the 3 Cs and the invest criteria in this user story. So that's it regarding the user story. So Khaled, how about we pull the next card from the think category?
Yes, Ahmed. The next card is the test list. And it says a test list is a comprehensive collection of test cases, scenarios, or tasks that need to be executed to validate the functionality or quality of a software system. It serves as a structured checklist or plan for developers prior to applying red-green refactor cycle.
So the test list is one of the TDD patterns that have been described in Kent Beck's test-driven development by example. And it's actually one of the TDD patterns that most teams don't do. And this is one of the reasons why most teams drop TDD or move to the test last approach, which is not really TDD. Because usually teams get stuck in how can I start? How should I start? Okay. And this confusions make the TDD experience a big mess. So the test list pattern is there to answer this question and to solve this problem. This is where you start thinking about what you want to test. Okay. And once you have that figured out, you start automating the tests in the test list. And from these automated tests, you start guiding the rest of the TDD cycle. So, Khaled, do we have a test list prepared to guide the rest of the exercise?
Yes, Ahmed. We wrote the following test list driven by the acceptance criteria, and it reads as follows. In the first test, we have an employee list with only employees under 18 years. So in which case we should return an empty list as none of the employees are over 18. In the second test, we have an employee list with only employees above 18 years old, and in which case we should return the complete list of employees. In the third test, we have an employee list with different age partitions, so to have a mixture of ages below and above 18, in which case we should return a list of employees 18 years or above only. In the fourth test, we have an empty employee list, which contains no employees. It's empty. The input is empty. We should return an empty list. And in the fifth and final test, we have a null list, in which case we should throw an exception and return an appropriate error.
Okay, so this looks like a very comprehensive test list. And going back to the card asks a very important question, which goes as follows. Do you use a systematic approach for writing the test list? Example, test analysis and design techniques. So the answer to this question is yes, we did use a systematic approach using test design techniques to formulate these tests. So we've used equivalence partitioning. And for those of you who don't know what equivalence partitioning is, so this is a black box test design technique where we have basically partitioned our data into different partitions depending on the data ranges that we have and the ones that should be included in the return list or the filtered list and the ones that are supposed to be excluded from the filtered list. And we've also used boundary value analysis. So boundary value analysis is very similar to equivalence partitioning. However, it does the tests at the boundaries. Okay. So if you've got something like the user story we're supposed to develop, you've got something that is greater than or equal to a number, that number starts becoming the boundary. And you want to write tests at these boundaries because bugs love boundaries. Okay. So we've used both test design techniques, and these are the partitions we came up with. So from 0 to 17 years of age, this is data that we are supposed to filter out. And from 18 to 150 years of age, this is the data that we should include in the filtered list. Okay. Of course, the minimum age and the maximum age is something that the team can discuss all together and with the product owner or with the business people. So based on that, we formulated this test list. And for the sake of this exercise, we're only going to automate this first test. And if you compare this list with the test before, this has been ordered differently. Why is that? Because going back to the card asks, do you prioritize or order the test list? And this is something that you are actually supposed to do. And if you get the TDD cards, you will find out that there are many other cards that help you determine which tests to start out with. And these patterns are from many different books and guidelines. So we've ordered the list. We've decided to start with this test. Employee list with different age partitions should return a list of employees 18 years or above. And yeah, this is going to be our first test. And we're going to ignore the rest just for the sake of time. Okay, so now that we have a test list, I guess we can start practicing red-green refactor, can't we, Khaled?
Yes, Ahmed, but first we need to learn about the 3 laws of TDD. The 3 laws of test-driven development are guiding principles that dictate: 1. Production code can only be written to address a failing unit test. 2. Unit tests must be minimal, failing as soon as possible, even on compilation errors. And 3. Only enough production code should be written to make the failing unit test pass.
Okay, that's great. So we've decided not to go straight into red-green refactor without first learning some of the recommended practices. And the 3 laws of TDD that were invented by Robert Martin, Uncle Bob, and very well described in his famous book, Clean Code, are really good guiding principles to run your red-green refactor cycle. So the first law says that we should follow a test-first approach, and that's actually going to be our next card. So we shouldn't be writing any production code until we first write a test. And this is what makes TDD a test-first approach, because otherwise it's test loss. And as we've mentioned, test loss is not really TDD. And the second law says that we should see the failing test. We should see the test fail at runtime and not at compile time. And the third law states that we should write just enough production code to see the test go green. Okay, so let's move to the next card. So now we're going to start the red-green refactor cycle. We are done with the think phase. We've written a user story and we've written a test list, and we've decided to just implement one test. And before starting with red-green refactor, we pulled out a card from the recommended practices, and that card described the 3 laws of TDD. And now that we know the three laws of TDD, we're going to let those and the rest of the cards we're going to pull guide us through the exercise. Okay, so now we are at the red bar. So let's pull a card from the red bar patterns and see what that card is about. So Khaled, go ahead.
Yes, Ahmed, this is the test first card from the red bar pattern. In test-driven development, tests should be written before the production code.
Okay, so as we've said previously, this is what TDD is all about. TDD is a test-first approach, and this is what Kent Beck says in Test-Driven Development by Example, and this is what is stated in the three laws of TDD. And if you get the card deck, you will find out that there are many more other principles that state that you should first start with a test. Okay, so now that we know that we're supposed to be writing, starting with a test, how about we move to our code editor and start actually implementing the automated tests? So Khaled, the floor is yours.
Yes, Ahmed, thank you. We will first start by writing a test class. We will name it accordingly with our requirements going to be employee filter test. And then we're going to write a test method. That's going to be, and we will call it accordingly to the test that we're writing. Our test, when we are giving a list of employees, when the list of employees contains partitions of all ages, then we return only employees 18 years or above. This is the
So
test name.
let me interrupt you here, Khaled, and tell people why we wrote the name of the test method this way. It looks very long, but this is actually a recommended practice. You should follow a naming convention for your test methods in order to achieve one of the benefits of test-driven development, and that the tests act as documentation for your code. So here, Khaled decided to use a naming convention where he starts with the action that the test is supposed to execute, or the function that the test is supposed to run against, and then the expected outcome. And there is a card in the red bar patterns that actually talks about formulating naming conventions in your working agreement, project charter, coding standards, whatever. Okay, so sorry for the interruption, Khaled. You may proceed.
Thank you, Ahmed. Now, on writing the actual test, we're going to structure our test in the arrange, act, and assert pattern. In the arrange phase, we prepare the input. Here, the input will be the list of employees from all partitions. I just prepared it in here. See, this is a list of all the employees. Okay, the IDE needed to be refreshed. Yes, this is the arrange phase, and our input, the list of all employees or employees from all partitions. In the act phase, we should run our actual code where we filter the employees from the list. we'll just assume that we have a method that's called filter employees 18 years or above, which will take our input, all the employees, and then it will return yet another list of filtered employees. We will make such for now, and then we will move on the assert phase, where we assert that the returned list, after we invoked our logic, after we've done our filtering, that the list returned is equal to our expected list. So we're going to make a list of the expected outcome, and I've just prepared it here. So this is the list of expected employees. As you can see, in the input contains only 2 employees that are 18 years or older. These are the expected ones to return. So I already prepared them. And then we're going to assert that these two lists are equal. We're going to assert that the expected list is equal to the one actually returned from our code. Now we're done with writing the test itself. So this is a test first. We will need to make sure that it fails. So we will run the test. And it failed indeed. It's in a red bar pattern.
Wonderful. So now that we have a failing test, let's move to the next phase. So we're now at the green bar, and we want to pull a card from the green bar patterns. So we've pulled the fake it card. So Khaled, why don't you tell us a little bit about that?
Okay. Fake it refers to temporarily implementing a quick and minimal solution that makes the test path without fully adhering to the desired functionality or behavior. It involves providing a hard-coded or stubbed, also known as a test double, response to the test, allowing the test to turn green while deferring the complete and correct implementation until later iterations.
So one of the mistakes that a lot of teams do when they're practicing TDD is that TDD turns out to be just red, green, red, green, red, green, and there's no refactor in that process. The reason why is that in the green phase, they start implementing the actual code with the final design, and this is not actually what the green bar is all about. So in the green bar, there are a number of patterns which allow you to write just enough code to see the test pass. And once you see that test go green, you then move to the next phase, and that is the refactor phase. And you start doing the actual design of the code, and you start working on the code so that it would be the real code and provide the real functionality it is intended to provide. All of this given the safety net that you have from the test that you have written. So this is actually what we're going to do right now in order to make the test go green. So Khaled, back to the code.
Okay, so we are at the red bar phase, and we want to go to the green bar. I think the simplest way to match our expected employee list is to return the list itself. This way we have faked the returned answer, and we should be getting a green bar. And yes, indeed, the test passed.
Okay, so we've seen the test go green, but we've actually faked the result. Okay, so in real life, there's not going to be a static list that is going to be returned. There's actually going to be some logic that is going to filter out the list with the employees that are 18 years or older and return that list. Okay. But we will do that in the refactor phase. Okay. We're now done with the green phase and we've seen the test go green and we've written just enough code to see the test go green. So let's move to the refactor phase and let's pull out a card from that category. So the card is about evolutionary design. So Khaled, why don't you read that out for us?
Yes, Ahmed. The evolutionary design, also known as incremental design, is an approach where the design of a software system evolves gradually over time through iterative development cycles. It emphasizes starting with a simple initial design and iteratively refining and expanding it based on changing requirements and feedback, resulting in a system that evolves organically and adapts to emerging needs while maintaining flexibility and scalability.
Okay, so these cards recommend that we do evolutionary design. Okay, so we start out with a very simple design and we run the test and we see the test go green again. And then we keep on improving that design until we reach to a point where we are satisfied with that design and that design actually delivers maintainable code that requires very little effort to maintain and modify and follows software design principles and their corresponding patterns, etc. So back to the code, Khaled. Let's refactor the code that we have right now and follow an evolutionary design approach.
Okay, Ahmed. I think also the simplest way to do so is just to loop on the list of employees, the input, and then extract the ones that fulfill our requirement. So we will need a list that will contain the returned result, which is going to be filtered employees. I will make it an empty list. And then we're going to loop on over the input list. So and write our looping logic here. So we're going to write if the employee, the current employee, if the age equals or greater than 18, then we need to add it to the returned list. So we're going to add that employee. And then finally, we will return filtered list of employees. Once we've done the refactor, we can rerun the test to make sure it works. And yes, it went green.
Okay, so that's not bad. Now we have an actual implementation of the logic that is supposed to return a filtered list. However, this code looks really old. I'm sure that Java has new features that would allow us to implement the loop and the logic inside the loop in a way that is a little bit more elegant. So how about we do another iteration of refactoring, Khaled? So do you have any ideas?
Yes, Ahmed, we could write it in a more declarative manner using the Java Streams API. So it is much more readable. So it goes like this. We create a stream of our input, and then we filter the employees where employees age is 18 or more, Then we collect the filtered employees into a list and return that list. Then we delete our old implementation, and then we rerun the code again.
Wonderful.
And it went green.
That's great. So far we've been writing the code, the production code, inside of the test class. So I think it's about time now that we move that code into the production folder, or the actual production code. So yeah, why don't we use the features of the IDE, the refactor features, in order to do that extraction?
Okay, Ahmed, let's create the employee filter class that will contain our logic. Here we're going to extract our logic in a method, which we will move later to the employee filter, but for now we're going to extract it in a temp method, for example. Temp, okay. And then we can move this method to our employee filter using also refactoring from the IDE. We're going to move this method and make it public to the employee filter into refactor. And then we're going to name that method from temp to the right name, which is filter employees 18 years or above. And then we will run our tests to make sure that we didn't break anything along our refactoring. And nice, it went green.
Looks really nice. And the approach we followed, and that is writing the code first inside the test code and then extracting the code to the production code. This is actually an approach that we've learned from Kent Beck. And the nice thing about this approach is that it allows you to first worry about the behavior and then later on worrying about the structure. And it allows you to develop tests that are behavior sensitive and structure insensitive. So as you've noticed, the method we've created inside the test class, it acted as a sort of an intermediary or an adapter of some sort. So all the changes that we've done to the structure was in that method, and we didn't actually touch anything in the test method itself. And this is a good approach, and you will find out in many books talking about test automation and test-driven development that this is actually a recommended approach. It allows you to build more maintainable tests. Okay, so now that we have done think, red, green, refactor, let's move to the last phase in our cycle, and that is the integrate phase. And we're going to pull a card out of this category and see what it's all about. So yeah, this card is about source control. So Khaled, why don't you read that out for us?
Yes, Ahmed. Source control, also known as version control or source vault, is a system that tracks and manages changes to software code, allowing multiple contributors to collaborate efficiently, maintain a history of alternations, and ensure code integrity.
That's great. So we know that all software teams use source control, okay? But the thing is, how frequent do you commit or push code to your source control repository? This is what the integrate phase is all about, okay? It guides developers to push their code to source control every time they finish a red-green refactor cycle, okay? And you get many benefits of that, okay? It's a way of pushing stable code frequently to source control, running your CI/CD pipeline, getting continuous and more frequent feedback, etc. So that is why we put this, and it's not actually us, that is Mike Hill in microtests. So this is why this is a very important stage that you should put at the end of every TDD increment or cycle. So Khaled, now that we know the importance of pushing code frequently to source control, how about we do that to all of the work that we have just done right now?
Okay, Ahmed, we can use Git client here from our IDE, and we should write a meaningful message. That is, write test 1 of these 18 or above. And then we commit our changes. And it's committed.
Okay. So now that you know that this is something that you're supposed to do in the TDD cycle, you will then start worrying about using a certain conventions for your commit messages. You're going to start thinking about should I do trunk-based development, or should I use some branching strategy like get flow, for example, okay? And then you have to worry about the other stuff in the integrate phase, like continuous integration, peer reviews, etc. So yeah, so now that we are done with the integrate phase, let's pull a card from the measure category, and that's actually going to be the last card we will be working with in this exercise. So the card we've pulled talks about code coverage. So Khaled, why don't you read that out for us?
Surely, Ahmed. The code coverage card from the measure category reads as follows. Code coverage is a metric that measures the percentage of code lines or branches that are executed during test runs. It quantifies how much of the code is exercised by the tests. Code coverage is used as a measurement in TDD to assess the thoroughness of the testing process and identify areas of code that may not be adequately tested, prompting developers to write additional tests to increase coverage and ensure better overall quality and reliability of the software.
Okay, so code coverage is one of many measures or metrics that we can use to measure the quality of our tests. And of course, this is not the only card under the measure category. There are many, many other cards under that category that explain and describe many other important metrics that can be used to measure the quality of your tests and the overall efficiency of your TDD practice. Okay, so going back to the IDE, Khaled is going to show you the tool that he uses in order to measure code coverage. And it's actually going to show us what is the code coverage of the tests we have written to test our production code. So Khaled, the floor is yours.
Surely, Ahmed, thank you. We can use the code coverage feature from the IDE, run the tests through code coverage. It runs our tests and gives us a report. we can find a 100% coverage on the employee filter class, a 100% on the methods of that class, which is basically one method that we just wrote, and a 100% coverage of the 3 lines in those in this method. So it showed us that perhaps our code works well, as it has 100% coverage.
Okay, so take care that code coverage is not enough. You need to be using other metrics like mutation score, etc., in order to measure the quality of your tests. And there are cards for that. And of course, you can read about mutation testing, etc., in resources that are online. So yeah, that was our exercise for today. So we've used the TDD cards basically to run a full TDD cycle on a single user story and on on one of the tests that were written in the test list. So let's do a recap. So the first card we've used talked about using user stories in order to clarify requirement and define the scope of work. The second card was about test lists that serve as a roadmap for your development and ensures comprehensive test coverage. The third card was from the recommended practices category, and that explained the 3 laws of TDD. Then we pulled a card from the red bar patterns and a card from the green bar patterns. And then we've pulled cards from refactor, integrate, and measure, basically to guide us through these different stages in the TDD cycle. So we've used 8 cards out of the 50 cards that are in the card deck. And you can imagine what other cards that are there and how useful they can be in improving your TDD experience. So I hope you've liked this mini workshop that we've delivered for you today. And thank you very much for waiting that long. And I think that now we can do the big announcements that we were saving till the end of the session. So the first announcement is that Tech Cafe is offering 3 free guided workshops with the TDD cards. So if you're a team that is already practicing TDD and you want to improve your TDD experience using the cards, we're offering 3 free workshops. So scan this QR, fill in the form, and we will contact you to schedule a free guided workshop with the cards. And obviously, we will be giving out at least 1 card deck for free to the team that is going to book a guided workshop. So we have coming TDD workshops in November. So the first workshop is on November 11th. That's the fundamentals workshop. So if you've liked what you've seen today and you wanna, experience the complete workshop for the fundamentals of TDD, you can register today to the workshop. Seats are limited, so book your place right now. We also have an advanced TDD workshop that is coming on November 25th. So if you want to take your TDD practice to the next level and learn all about the advanced topics in TDD, book a place now in this coming workshop. And since you've waited that long with us, we are offering a promo code that will give you 10% off any of the workshops that are coming up for TDD. So when you are registering to the workshops, make sure that you enter this promo code that is in front of you right now, and you will get a 10% discount off the workshops fees. And we have more sessions coming up in the Tech Cafe podcast. So on November 7th, we are hosting an episode titled Measuring Developer Productivity. And we have really great guest speakers that are going to be with us. We've got 𝗂𝗲𝗃𝗀𝗃𝘀𝗵, Riham Saleh, and Mohammed Hussein. So we're going to be discussing the recent McKinsey article on measuring developer productivity, and which has caused a lot of controversy and discussions in the tech community. So we're going to be talking about that, and don't miss that out. It's going to be a great session. We also have a session coming up on November 14th, where we'll talk about the anti-patterns of TDD. So don't miss that out. It's going to be another great session by Tech Cafe. And last but not least, the renowned and well-known Valentina Kopacz is going to be delivering a great episode in December 6th, titled TDD in Clean Architecture. So whether you are a back-end developer or a mobile developer using clean architecture as your software structure, and you want to practice TDD on that, don't miss this session out. Valentina is a great TDD coach and practitioner, and she's going to show you hands-on how to practice TDD on clean architecture. So that's all that we have for you today. So on behalf of Khaled and myself, I'd like to thank you a lot for waiting and that long. We hope you've enjoyed this session. And yeah, I see we don't have any questions on the chat. So I guess we'll be ending it here. Thank you very much. And we'll see you in the coming session.
We'll see you. Thank you, Ahmed.